Hello everyone. Today we shall discuss about SHM, simple harmonic motion. In simple harmonic motion, today we'll deal with velocity and acceleration in simple harmonic motion. Today we are going to deal with velocity and acceleration, velocity and acceleration, velocity and acceleration in simple harmonic motion. In simple harmonic motion. In simple harmonic motion. Simple harmonic motion. So today we are going to discuss with these things that velocity and acceleration in simple harmonic motion. In the previous class, when we discussed about the displacement, we got in projection method that the displacement will be the particle has a displacement on the x-axis as xt dependent on x, dependent on time, and that is dependent on a cos omega t plus phi. What is phi? Phi is the initial phase. Here let phi is equal to 0. Phi is equal to 0. Therefore we got the equation as x time dependent, and it is a cos omega t. A cos omega t. Now if we differentiate this, we know that velocity is equal to dx by dt. We know this one. And acceleration is equal to dv by dt. So we'll use this differentiation here to find the velocity and acceleration. So velocity can be defined in this way as velocity on time dependent factor, it will be dx by dt. Dx by dt. You know that how to differentiate this one. The differentiation method is, there is a formula that I am going to discuss here with, right? What is that differentiation? This is a constant, k is the constant, so a. What is the differentiation of cos? It is, that if x is equal to cos theta, then dx by dt, then dx by dt, rate of change of x with respect to time will be minus sin theta. We know this one, right? So we are getting at is as minus a. This will be equal to differentiation of a cos omega t can be written here as minus a. The differentiation of cos omega t is sin omega t, and you see this omega is multiplied with t, so therefore another omega will come, right? Therefore getting the velocity as velocity and time dependent factor, that is going to minus omega a sin omega t. We can find this also in projection method, but here we are using the differentiation method for finding the velocity and acceleration. And you see, if you want to find the acceleration, it is also time dependent. It can be written as dv by dt. And here we will find that if x is equal to sin theta, then dx by dt is equal to cos theta. We know this one, right? So here we will find is equal to minus omega a. Differentiation of sin theta is cos theta, that is cos omega t. And you see, there is a multiplication of omega here, so it will be called omega t. Omega is multiplied with t, there will be another omega, that is omega. So here we are getting acceleration minus omega square a cos omega t, right? So we are getting three things. One is this one, equation 1. This is displacement with time, equation 1, and this one is velocity with respect to time, and this one is acceleration with respect to time. So we are getting three equations. Now we will give the graph of these three equations such that you can understand which type of graph will be here. So you know that in case of oscillations or time period, the total time period can be divided into four parts. For example, there is a spring here, and it is, suppose it is the mean position, right? And the spring of the ball is going here and there, here. So what you call it here as the B is the mean position, and A and C as the extreme position, right? We know this one. So for obtaining the graph of xt versus omega t, we will plot the graph here. So you here, let us find in the next page, we will find the graph, right? So first of all, we are writing that x equal to a cos omega t, x dependent on time equal to a cos omega t. So we will find the graph of x versus time. X is the displacement and t is the time it required, right? So we are plotting this graph in this way. We see how we are trying to plot the graph in this way. So we are plotting three things. One is x and one is time. Suppose this is x and this is t. So you have to take 5 points: 1, 2, 3, 4 and 5, right? Now how we are going to find this point, that is important. First one, at time t is equal to 0. If you put the value of t, what you will get, that is interested for us. So at time t equal to 0 here, you see here that x is equal to a cos omega t time is 0, so cos 0. So the value of cos 0 is 1, so it is a into 1 equal to a. So at time t equal to 0, the value of x equal to a, right? Okay. Now number 2, at time, this is at time t equal to 0. If I say what is the time, what is the position of x at time t is equal to t by 4, t by 4. So here you can find that x is equal to a cos, what is the meaning of omega? Omega equal to 2 pi by t. Omega equal to 2 pi by t. So in place of omega, you can write 2 pi by t into this t by 4. T by 4. So these t will cancel, and 2 is 4, cos 90. Cos 90, value of cos 90 is 0. The value of cos 90 is 0, so it is 0. So here, when the time is t by 4, the value is 0, right? Now we are getting third equation, that is at time t is equal to t by 2. At time t equal to 2, what do you get? The value of x is equal to a cos 2 pi by t into t by 2. So these two will cancel, this will cancel, so cos pi. The value of cos pi is minus 1. So the value of x is equal to minus a, right? So you're getting at t by 2, the value of x is equal to minus a. Again we are getting the value at 3t 3t by 4. 3t by 4. What is the value? So we are getting at time t is equal to 3t by 4. The value of x is equal to a cos omega, means 2 pi by t, and this is 3t by 4. 3t by 4. So this will cancel, and 2 is 4, right? So it is 3 pi by 2, 3 pi by 2. So it is 270 degree, 270 degree. A cos 270 degree. Now I want to find what is the value of 270 degree. If you find that 270 degree, then that you can write here in this is cos 3 into 90 degree plus 0. So it is 3 into 90, that means your cos will change into sine. It is changing to sine 0, right? And sine 0 means value is 0, so it is 0. So the value here x is equal to 0. So the value will be 0, right? And the fifth one, you will find here that if x is equal to, if we are going to find the t at time period capital T, right? So how we find the value of capital T? We can find the value of like capital T like this: x is equal to a cos 2 pi by t into t. So this will cancel. Cos 2 pi means 360 degree. What is the value? You can find here that cos 360 degree. You can write it in this way, that cos 360 means 4 into 90 plus 0. So it is 4, it is cos 0, and it is in the fourth quadrant or first quadrant. So it is positive. Cos 0 is 1, the value is 1. So we are getting the value here as A, right? What is A? Is the amplitude. Now we can draw the displacement time graph very easily. So we are plotting this graph here, you see here, this one. We are plotting the graph here. You see, we are trying to plot this graph that x equal to x versus time. So it is in this way you can find that this is the straight line, this is a straight line, and you see the x is a plus a means plus amplitude plus a, and this is minus a. So the value for x equal to 0, the value of x equal to a, so this point we are getting, right? For t equal to t by 4, so if we divide this part into equally 4 parts, 4 equal parts, 1, 2, 3 and 4, right? So this part will be t by 4, right? Because t by 4 means this one like this. Suppose this is the particle, it will go here. So this part position is B, this position is A, this is position C. When the particle goes B to A, it is t by 4, and when coming it from A to B, it is t by 2, right? So it is t by 2. And when it is coming B to C, it is 3t by 4, 3t by 4. And when it is coming back to B, one oscillation, that is t. So we have taken 4 points, 1, 2, 3, 4 and 0 also, that is 5 points, right? So at the point t is at time t, the x velocity, the displacement is a, right? So what we are getting here is this is a point, this is x is 0 and time t by 4. So the value of x equal to 0 here at time t by 4. And at t by 2, the value is minus a. So we are getting a point here as minus a. You see here, this is 0, t by 2 and minus a, this one. And again we are getting the value here, that is 0 at the 3t by 4. At time t, it is plus a. So this point we are getting. So we are getting this point. So if we draw the graph of this, you will get a curve like this. You see here, we can get a curve like this. right? And it will be like this, and it will be like this. So this is the this is the graph between displacement and time. So this is a graph of displacement, graph of displacement, graph of displacement versus time in simple harmonic motion of equation x is equal to a cos omega t, a cos omega t. So here we find the graph of displacement versus time for the graph for the equation a cos omega t, right? Now we find the graph of displacement. You see here what type of value is going to get here. So x is equal to a cos omega t, a cos omega t. If you find velocity, then it will be dx by dt, right? So we are getting the value as that minus omega a sine omega t, sine omega t. This is the velocity, right? So we are going to draw a graph between velocity and time. So we have to take 5 points again. So take these 5 points and you get the value here. Take the 5 points here. You are getting this value in this way. This is the middle line and get 5 points, right? After that we will draw the graph. This is velocity and this is time. So we'll get the equation for velocity time graph, right? So let us find what type of how you have to take 5 points, 1, 2, 3 and 4 and 5. So you have to take 5 points, right? Now at time t, this is 1, at time t is equal to 0. If I take the time t as 0, what will be the velocity? So here v is equal to minus omega a sine 0, that is the value is 0. So at this point t equal to 0, the velocity is 0, right? Number 2. At time we are getting at time t by 4. What is the value? Then velocity will be minus omega a sine. The value of omega is 2 pi by t into t by 4. Given the value this t to pi by sine 90. Sine 90 is 1. So the value is minus omega a, right? So the value is at this point, that is at t by 4. T by 4 the value is minus omega a, right? Now you get the value at t by 2. Number 3 is at time t is equal to t by 2. So we get the velocity here as minus omega a sine, omega means 2 pi by t into t by 2. So this should cancel, this should cancel, sine 180 degree. What is the value of sine 180 degree? We can find the value of sine 180 degree, sine of 180 degree. So you can write sine 90 plus 90, 90 degree plus 90 degree, it is 90, so it will be cos 90, and cos 90 is 0. So the value at this point, that is t by 2, the value is 0. Now we'll find the value, next value as 3t by 4, 3t by 4, right? So we get the fourth point, that is at time t is equal to 3t by 4, 3t by 4. What we are getting? That we are getting the value v is equal to minus omega a sine 2 pi by t into 3t by 4, 3t by 4. So you're getting this will cancel, 2, 2. So 3 pi by 2. 3 pi by 2. That means 3 pi by 2 is 3 pi by 2. So the 3 pi to 70 degrees. So we are getting minus omega A sine of 270 degree. Now what is the value of 270? You see here, sine of 270 degree. So you can write it here as sine 90 into 3 plus 0. So you are getting the value sine 90 plus 90 into 3. Sine 90 is there, so it will be cos 0, right? And what is the value here? 270, that is, it is fourth quadrant, it is sine is minus cos 0, minus 1. So we are getting the here as minus 1, so we are getting it is plus omega A. So this is plus omega A, plus omega A, right? And at the last point, that is fifth point, at time t is equal to time period, t equal to time period, then the velocity will be what we are getting, minus omega A sine 2 pi by t into t. This t equals sine 2 pi 360 degree. What is the value of sine 360 degree? Sine of 360 degree. That means you can write sine 4 into 90 plus 0. So it is sine 0, value is 0. So the value is 0 here. So at the point time t, the value of the velocity is 0, right? So now we can very easily draw the graph velocity versus time. So here is the line or graph. Right? So the highest value will be here plus omega A plus omega A, and the least value is minus omega A minus omega A, right? Now we are getting the value 4 points at t equal to 0, the velocity is 0, this point. At t by 4, we divide this part into 4 equal parts. 1, this is the middle, this is this one, this one. So right, this is t by 4, this is t by 4, this is t by 2, this is 3t by 4, and this is t, right? So we are getting all these points. So at t by 4, the value is minus omega A, so we are getting this point here, right? And for t by 2, the value is 0, the value of velocity is 0, so this point we are getting. At 3t by 4, the value is omega A, so we are getting this point plus omega A. At time t, this is 0, so we are getting these points. So if we draw this graph, will be like this. You see, the graph will be like this, right? And this is the graph. So here we find that the this is the time axis, time, and this is the velocity axis. This is velocity v. In this way, you can find the different graphs. This is velocity, this is time, right? Now this is for velocity time graph. This is velocity. This graph is velocity time graph, velocity time graph of SHM of equation x is equal to a cos omega t, right? Now we'll find the graph of acceleration, right? So we'll take another page and going to find the acceleration. So now we are finding the acceleration. So x is equal to a cos omega t, right? So the velocity will be dx by dt equal to minus omega a omega a sin omega t, and the acceleration a is equal to dp dt, that is equal to minus omega square a. In place of sin, it will be cos omega t. So we find the relation between acceleration and time. So here we are finding the 5 values of acceleration versus time. So we have to find 5 values of this one. So let us find the 5 values here. So what we are getting here is, one is acceleration and time. This is a and this is time. We'll get 5 values: 1, 2, 3, 4 and 5. We're going to find for 5 points t equal to 0, t is equal to t by 4, t equal to t by 2, t equal to 3t by 4, and last one is at point t. The first point, at time t is equal to 0. So at time t equal to 0, you'll find that it is acceleration is equal to minus omega square a cos 0. Cos 0 is 1, so value is equal to minus omega square a. So at time t equal to 0, the value is minus omega square a, right? Now point 2, at time t is equal to t by 4. At time t by 4, you will get the value a is equal to minus omega square a cos omega means 2 pi by t into t by 4. So it is t cancel, pi by 2 cos 90, that is 0. So the point is here, we get the value as 0. And the third point, at time t is equal to t by 2. So getting the acceleration is equal to minus omega square a cos 2 pi by t into t by 2. So this t cancel, this 2 cos pi. The value of cos pi is minus 1. Value of cos pi is minus 1. Therefore the value is equal to minus omega square a. Here the value is minus 1, that is plus omega square a. Here the value is b plus omega square a, plus omega square a. Right? Now we get the value of 3t by 4 at the point number 4 is at time t is equal to 3t by 4. 3t by 4. So we are getting acceleration to minus omega square a cos omega is to pi by t into 3t by 4. 3t by 4. So we are getting this t cancel, 2 to the 4. So 3 pi by 2. The value of cos 270 degree. The value of cos 270 degree is 0. Right? So we are getting the value here as 0. This is value is 0. And at the fifth point, you are getting the here as at time t is equal to capital T. So acceleration will be minus omega square a cos 2 pi by t into t. So this will cancels, and you are getting the value at time t is equal to, that is the value of minus cos 2 pi means cos 180 degree. What is the value of cos 180 degree? Cos 180 degree, well, we can write cos of 90 plus 90. So 90 plus 90 sin 90, right? And second quadrant cos 90 minus 90 sin 90, and sin 90 is 1 minus 1, so it is minus 1, minus into minus, it is plus. So you get so in second cos in second quadrant, cos of this what is getting 2 pi means 360 degree, not 180. Okay, cos of 360 degree, what is getting 360 degree. So you are getting the value cos 90 into 4 plus 0. So it is cos 0 degree, and 90 plus 4 plus 4/5 in this first quadrant. Cos is positive, so cos 0 is 1. cos 0, so the value is minus omega square a. So this value is minus omega square a, right? Now if you draw the graph, so let us find for what is the type of graph here. The type of graph will be like this. You see here, this will be the graph, right? So this value is plus omega square a plus omega square a, and this value is minus omega square a, and here we'll find 3 points, 1, 2, 3 and 4. This is time t equal to 0, this one, this is t by 4, this one is t by 2, this is 3t by 4, and this is time t. How we'll find? You see the first point is 0 minus omega square a. The value is 0 minus this point, this 1 point I'm getting here. And second point t by 4, it is 0. Third point, it is at t by 2, it is plus omega square a. Third point, it is plus omega square, this point I'm getting. And 0, 3t by 4, it is 0. And at it is minus omega square a. So this point is minus omega square a. So if we draw the graph, we'll find like this. So here we are finding the acceleration versus time graph. Graph of acceleration versus time, acceleration versus time, graph of acceleration versus time, graph of acceleration versus time, graph of acceleration versus time in SHM of the equation x is equal to a cos omega t. X dependent on time, that is a cos omega t. So this is the graph versus acceleration versus time. This is the time axis and this is the acceleration axis. So we are getting the different graphs here of displacement time graph, velocity time graph, and acceleration time graph for a simple harmonic motion with this equation x equal to a cos omega t. Thank you everybody for watching this video.